Okay, so we can start. So once again, hello everyone, and welcome to today's event by MTL NLP Consortium. And as you all know that today's topic is going to be on dialogue systems, and we're going to have three very interesting presentations today. But before we start, we'd like to go with Dr. Laurent Charland from HEC Montréal. Will have a few remarks. And without further ado, I'm going to pass the podium to Dr. Charland. So,
Thanks. I feel like a dignitary that would sort of wake up on stage, just be there for a few minutes and then leave again. No, so I'm very happy to be here. I'm happy to see everyone. So even though the world is changing, seems like your motivation for dialogue system is staying intact, which is very nice to see. I'm glad we get to convene today to talk about some of these things. I think also perhaps a silver lining of the current situation is we are able to have researchers from not only Montreal that could be here physically, but people that may have a nice and interesting link to Montreal, but aren't physically in Montreal right now to give some of these presentations. So that's perhaps the silver lining of the COVID. And I won't say much more except to maybe just briefly mention that I think these three talks are extremely interesting, especially in our setting, because I guess it seems to me like they combine very interesting fundamental research, but with a very clear practical appeal, right? And so I think, especially for this group of people, these are going to be three very good papers and three very good researchers to know about and follow for the years to come. So thank you very much, everyone, for being here. And without further ado, I'll give the presentation back to Harm, I guess, or Sam, do you want to talk some more?
yeah, I'll just add something. So as Dr. Shala mentioned, it's a very good opportunity that now with the COVID in place, there's actually a silver lining, and everyone is like the world is unified, and everyone are here, and we can have the opportunity to have speakers from all around the world, and there will be no limitations aside from apart from the time differences, but still it's going to be much easier. And we are actually happy that it's been a while due to COVID. These events did not continue. We had a few of them previously, but they kind of stopped after the COVID. But I'm happy that they're kind of starting again, and we'll have one this month and one in the upcoming month. So it's really exciting. So before starting the first presentation, I would like to ask the audience a few things. So if you can kindly turn off your cameras and also turn off your microphones during the presentation by the main speaker, that would be greatly helpful for everyone to enjoy the presentation and get the most of it. So the first talk is going to be by Harm de Vries from Element AI, and the presentation is going to be towards ecologically valid research on language user interfaces. So without further ado, please welcome Harm.
All right. Thank you so much for the introduction. Like Laurent said, I'm actually currently in Amsterdam, so that's why it's already dark here. So I apologize in advance for probably that you can't see my face very well. But I mean, nevertheless, I hope I can bring some interesting perspective and discussion on dialogue systems today. And I'm going to share my screen. Yeah, I hope this is working. Yeah, so here we are. And so I'm really excited to talk about a recent paper that we just put on arXiv, I think a month ago now. And this is it's a joint work with my colleague Dimitri Balanau at Element AI, as well as Christopher Manning, who is a professor in NLP at Stanford. And this type of work actually is a position paper, which I think fits very, very well in the topic of today, because we have a lot of industry researchers here today, and sort of there's always this question of people are doing this fundamental research in academia, but how can we make sure that this research actually transfers into sort of real applications that people can use and sort of are sort of really moving the needle in terms of tech adoption. And so basically, this is one of sort of like the main ideas of, or like the positions that we're taking in this paper. And the position is that there's a lack of ecological validity in a lot of like academic benchmarks for language user interfaces that really undermines sort of like the progress that the field is making on these type of systems. So of course, like this is just the takeaway. Like I'll go into depth about like what it actually means, what ecological validity means. But if you want to sort of like remember, so like one sentence about this talk, this is the one that you should remember. Great. So first, language user interfaces. I don't think I have to spend too much time on this in this audience. Like, I mean, popular examples are like personal assistants like Siri and Google assistants. You can think about assistants for business analysts. So people who are like accessing databases, which they could do through like natural language, for example, or like more these chat systems that can help people purchasing goods, for example, and get sort of like support for that. Other things are assistants for the visually impaired, so blind people that can ask questions about their surroundings, or what you see right now is like those domestic appliances like TVs or even domestic robots that could use a natural language interface or language user interface for humans to interact with these systems. Cool. So so that's about language. Those are a few examples for what language user interfaces are. What I should mention is that that actually like these are like more goal-oriented systems or like task-oriented systems. So like I won't be really discussing a lot of like more chit-chat system or like open domain dialogue systems. And like here I'm sort of like considering so like the research on more these task-oriented dialogue systems. Right. So then sort of like ecological validity, just like in rough outlines, what does this mean? Where is it coming from? And so this is a concept that comes from the psychology literature, and sort of like roughly means like, are your experiments, are they conducted under conditions that are representative of the real world? And sort of like a standard example in sort of like psychology is, for example, when they're doing research on jury trials. So, and a study with a set like that has low ecological validity could, for example, mean that they study where they give sort of like the transcripts of the case, like in a written form to the participants. And for example, in a classroom setting where sort of like for people sort of like to imagine what the case would look like and sort of like study like how they would respond to as a jury member to those cases. This is sort of like an example of what they call low ecological validity because it's not really, oh wow. That's not good. Are you still hearing me?
Yes,
Yes,
can
yes,
hear
I can hear
Yes,
you.
no problem.
Something happened?
Yeah, like are you guys still seeing my screen? Because like
Yeah,
Yeah, we can see your screen.
We can see page 7.
Okay, well, I guess like Microsoft Teams just dropped me out of the presentation, but I guess I'm back. So the idea here, just to come back, so if you're like these sort of like experience that the participants are going through are not the same as like what a real jury trial would look like, and so this is why they call this like low ecological validity. So like if you would do it actually with real participants in a real jury trial and try to do research in those settings, that's what people call like high ecological validity. And so like we're going to sort of like study like or look at natural language interfaces through the lens of like ecological validity, and then in particular like the academic benchmarks that were that are currently studied or like worked on a lot. Great. So maybe before we're gonna like look at an academic benchmark, let's first look at sort of like the ideal case or of like what would it mean to set up so to basically study language user interfaces with high ecological validity, right? What's sort of like the gold standard for doing research on these type of systems? And sort of like, I think the first thing you have to realize is that like high ecological validity sense means that we want to study language user interfaces that people would actually like to use. So that probably would start with identifying sort of like a set of users that would need assistance with some particular task. And we'll sort of like, we've seen a few examples before about what these tasks could be. And of course, another important like consideration there is that the task or the language user interface that you're building should be somewhat better to sort of like alternative interfaces like graphical user interfaces or even terminals, or in the case of robotics, probably like remote controls. And sort of like these are the sort of like competing systems you have to like be more convenient for the user to use. So that's the first step. Then the second step is like you want to like we're going to consider machine learning systems. So I guess the second most important step is then to collect data for our systems to train on. And this is of course like a bit of the tricky part. Because we're kind of we don't have the system yet, and we still want to sort of like collect data that is representative of the system we want to build. And to sort of like bootstrap ourselves out of this sort of like chicken and egg problem, we need to, we often use a sort of like Wizard of Oz simulation, to collect the data. So what this, I'm not sure who's familiar with Wizard of Oz, but just very briefly, what it means is that we have on the one side, so like the end user who sort of like types the request in natural language to a so-called wizard in the middle here. And this wizard is translating the request of the user into sort of like machine understandable code. And ideally, this sort of like takes the form of a dialogue where the user can sort of like update their request, and the wizard sort of like pretends to be the intelligent machine that can understand and sort of responds to these requests. Great. So once we have that data, like you can of course use it just to train your machine learning model and sort of like have a sort of like system that can now take over the wizard's role and sort of like play the intelligent system that you were trying to build in the first place. Great. And then so once you have the system, I guess the fourth step of like doing sort of like ecologically valid research on that is to actually assess how well your model works according to the sort of like the population of users you're trying to build the system for. So this ideally, this requires a sort of like these users has to be in the loop to sort of like really evaluate like how satisfied they are with the system you've been building. And we'll come back to that later, I think. Great. So this is sort of like the gold standard of what ecologically valid research on this dialogue system would look like. But now let's sort of like look at sort of like the literature or like the common benchmarks that people are working on. And I should actually mention here already that this is like, I feel this is probably like the reason why people are so like deviating from the procedure I just outlined is that it's very expensive way to collect data. And so what, especially like if you have like these deep learning systems, they require a lot of data. So people have sort of like probably looked for like cheaper ways of collecting data in this domain. And so we'll see like a few examples of that. And number one is like, still very, very common here is like synthetic language. And so I'm not going to spend a lot of time on this issue because you can read the paper if you sort of like interested in the actual benchmarks. But what I want to sort of like at least tell you that it's really hard for synthetically generated language to have a lot of like linguistic coverage. and at the same time look very natural. So what you often see is either very simplistic, and what happens then is that the coverage is not enough, or it starts to become like very, very complex, and sort of like a lot of the utterances that are generated just look very weird and not all like sort of like natural language. And this is even harder in if you go to dialogue setups where you get like a lot of like more sophisticated linguistics phenomena that are even harder to cap with, so like grammars. Great. So number 2, which is artificial task, which is sort of another deviation, which is if you think about it, it's really a matter of you don't really care like that the system is really useful for a particular population. Basically, what you so like often can do is like come up with sort of interesting game or artificial task that does require a lot of sophisticated human-machine interaction in like through language at least. And this data is interesting and diverse and actually captures real linguistics phenomena, but these are not sort of like the language user interface that people actually want to use. And a sort of like particular example which is dear to my heart because it was one of my PhD papers or topics that I worked on for a while. And in which Sarath was also involved, and I think he will speak later today. And so the idea of this paper was, or like of this project is, so can we have like, it's a dialogue or more like a sequence of like questions that are targeted to find sort of like a target object in the image. So here we have sort of like the questioner agent that asks these yes/no questions. And there's like on the other side, there's an oracle agent or what you can call a wizard that answers with yes, no to these questions. And then at the end, the goal is for the questioner to guess which object was sort of like hidden from him in the first place. So that's one thing I should not forget to mention is that there's the green object here highlighted by the green bounding box that's not known in advance to the questioner. And of course, this leads to very interesting data, but the problem is that this particular task, this is probably fun for like a few rounds of playing, but then sort of like no one would be interested in sort of like using this on a daily basis. Right, so let's move on to number 3. This is a very common one. And this is not working with prospective users. And this is particularly prevalent now with Amazon Mechanical Turk, because like this is like a relatively cheap workforce that's like available to a lot of like researchers, but also like can so like come at a price. And we'll see like an example of that right now. So here's like the sort of like takeaway from this issue is that, okay, if you collect data from unrepresentative users, this might also lead to unrepresentative data. And the sort of like most famous or like most like interesting example is probably what people in academia call the task of visual question answering. And this is probably often more considered as a sort of like abstract task for measuring progress on language and vision tasks. But if you actually look at the abstract of this paper, they actually have in mind that this task is a proxy for like helping the visually impaired. So they really had in mind a sort of like almost like a language user interface where blind people can ask like questions about images. Right. Okay. So so how did they collect? So this is interesting. It was like how they collected their data is to actually ask human annotators, which have like actually perfect sight. They provide them with the following instructions. So we have built a smart robot, understands a lot about images. It can recognize and name all the objects. It knows where the objects are. It can recognize the scene, people's expression, etc., etc. Your task is to stomp this smart robot. So you can see that sort of like the task is actually, like in this case, it's given to like annotators with perfect sight and not the sort of like target population of blind people. And sort of like this has consequences for the type of questions that people ask. Like, and this has been pointed out excellently by a study that's called Vries, and they actually looked at the difference between questions that actually blind people ask versus like the questions that you can find in CLIQ-ai. And so like one thing they notice is that like the questions are more conversational in nature and often also like incomplete. They often start their questions with what, and they don't use other words to narrow down the answer space, like which or like how many, which you often find in CLIQ-ai. Another thing they found is that actually like it often requires text reading capabilities, so more like OCR. So blind people, of course, they can't read. So like these are actually like a prominent use case for this user population. And another thing is that often the image quality can be quite poor, or they don't, the pictures that blind people are taken are often don't have the object even at all in the image that they're asking the question about, or from a slightly strange angle, so it can be really hard to answer the question because of that. So another example of like not what can go wrong if you're not working with the prospective users, which can be found in the spider data set, which is a very popular cross-domain semantic parsing task. So people are asking questions which need to be translated in SQL. And here the way they collected the data was by asking 11 like computer science students to write queries, a few queries per database that would cover now a particular like SQL patterns. So here, of course, the issue is that these computer science students, they are familiar, they actually also have to write the program or like the SQL query here. And often what you would see is that they would probably start with the query and then sort of like back translate that to an image. And you can see sort of like artifacts of that, like where you find in the data set, which is like, what are the names of the customers who bought product food at least once? So there's like, if you look at the actual query there's a column name that's called product. So you get this, and the value is food. So there's like these strange artifacts just because they're the way they've set up their data collection. And there are other, you can easily find other like strangely formulated questions, just probably as a result of like the way because they didn't ask actually the questions from a real and from people with a real intent to access that database. Great. Number 4. Let me see how I'm on time. Okay, so good, I think. Yeah. So scripts and priming. So this one is actually this is a bit more subtle. Like here, what people often do in a sort of like Wizard of Oz setup is that they provide the user, like they don't have a real intent, so they provide them with a script or a prime to get a particular task done. And this can often come in sort of like scripts that they give to the users, which they sort of need to execute. And so a popular example in the dialogue literature is multi-was. And there the task is to, so you see here, let me see if you can see it here. Well, here you see the interface of the user, which is trying to ask, trying to find basically trying to book hotels or restaurants or like or anything else in this space. And but basically, it asks these requests to the wizard, which then sort of like translates that into filling slots in their backend system. And so this is a quite big data set for dialogue literature. It's like around 10,000 dialogues. The issue here is, or like when we looked at the data, one sort of like consequence you can see is that people are copying parts of the prompts. So you do get this like weird things like you are looking for a place to dine as a sort of, you get this description. The restaurant should serve Chinese food and should be in the south. So you get immediately like the dialogue. If you look at the first utterance, it's asking like, I need a place to dine in the south that serves Chinese. And I guess like almost everyone else would ask like, I'm looking for a Chinese restaurant, right? So people are just copying this part of the prompt and not sort of like using like more natural language to describe their intent. So that's number one. Another downside is that you can actually, it's really hard to accommodate for all the scripts and like possible scenarios that people want to do. Right? So if you look at multi-WAS, they have this rule that so you can try to book a hotel that might fill, and then they have like an alternative. For example, here in this case, they want to book it for 3 nights. If the booking fills, you can ask for 2 nights. But that's about it, right? That's like there's only ever like one correction possible. So like if there is a scenario where even my second request like cannot be fulfilled, then I cannot ask. Well, I can try to ask for another correction, but just my training data doesn't contain that. So you will never have support for this use case. And probably, I mean, we don't know, but most likely your model will fail just because it didn't see that kind of stuff before. Great. So number 5, and so this is getting more and more towards like an ecologically valid benchmark for natural language interfaces. And so like they don't suffer from the issues that I've mentioned before, but they restrict the, sort of like the interface to single turn. So it's not really dialogue, it's really people doing one single request. And yeah, that's about it. So popular examples are like the advising data set, which is again in this semantic parsing domain, where the way they collected the questions was by looking at the course information of the University of Michigan and actually like extract questions from their Facebook page. So like, examples are like, I mean, what special topic classes are there next winter? Or like some question about profs and teaching particular courses. So these questions actually make like a lot more sense and are a lot more natural. But of course, there is sort of it's not possible to ask follow-up questions that are related to your previous questions. And another example of this is like MS Marco, which is a Q&A, like question answering benchmark, in which they extract questions from anonymized logs of the Bing search engine. But and there's also like Google natural questions, and I think I'm not sure. Like I think there's also like a Chinese variant of that. But so the point here is really that it's again sort of like a single turn data set. And so like, why is this problematic, or at least like it's like limiting in terms of like ecological validity? And that's because like there's been so many like case studies like that date back to at least the 70s and 80s, where people are doing Wizard of Oz studies and sort of like show that people really, like, even if you try to restrict them, they really want to use dialogue to get things done. So there's a lot of like anaphora, ellipses, and meta-linguistic utterances that are used in these, like if you just like let the like communication channel freely open, that people would actually use, prefer dialogue over a single turn. And so this is an example like here from long time ago. It's like in the 80s, yeah, like a Wizard of Oz studies in a sales, simulating a sales assistant. And it's about like, so what's the largest blah, blah, blah disc under $40,000. It was very expensive back then. And then like the RPA AA is fixed back, blah, 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 cost 48,000. And then there's like this largest under 50,000, which is actually what they linguists call ellipses, because it doesn't refer, it omits sort of like the fact that we're still talking about disks, or like in this case, the 11780 disk. And this is still the same answer, the RP07AA. Right, so, and there are lots of other studies, like even in database QA settings, where they looked at like what kind of questions people ask, and they see a lot of like context dependency in those questions. So yeah, single turn is also another limiting factor. So these are like, I've been skipping, like just in the interest of time, skipping over a lot of like other studies, and so like I would sort of like suggest you to look at the paper, which you can find easily on arXiv if you either Google my name or the other authors, and sort of like the question, of course, is like, what else as a research community should we do, sort of like increase the ecological validity of our benchmarks, and sort of like avoid all those sort of like artifacts, hopefully that we're seeing in current benchmarks. And so I think like we sort of like identify a number of sort of like areas where we think it's possible to do like the research on language user interfaces, and sort of like collect large scale and high ecologically valid data. And so number one is like popular video game environments like Minecraft, where people can, well, where it would be easy to sort of like plug in maybe sort of like assistant or player that could be, we could interact with through language, and like that is a platform that already has a lot of users, so we can hopefully like plug it in. There's an initiative by Monica Lam at Stanford to sort of like build an open platform or language user interface that can basically talk to all your devices on the Internet of Things. And I think that's another sort of like promising area where you could do research with high ecological validity. And the last one, which is what our group at Entailment is quite interested in, and that's just like building language user interfaces for statistical data that are, for example, published by governments or other big agencies that can make their data available. But yeah, so these are directions. But another thing we think what could be interesting to pursue here is that even if it might be hard to collect sort of like large scale data sets that have high ecological validity, we could perhaps start with collecting like smaller data sets for testing purposes. So then you would use probably cheaper forms of data, for example, synthetic data for training, and maybe mix it in with paraphrases or other data that has higher ecological validity, and at the same time evaluate your system on a data set that has it doesn't suffer from like low ecological validity. And so like finally, what I suggest is, one of the problems, of course, with low ecological validity is that it's unclear if the advances or the progress that you're making on that benchmark actually translates to better systems, like in practical systems, right? So like one way to sort of like avoid these problems or like of like ecological validity is to really think about like what are the conceptual research ideas that can really generalize beyond the current data set and really have a chance or are likely to transfer to setups with high ecological validity. And yeah, I guess with that, I would like to thank you for your attention, and I'm happy to answer any question.
Okay, so thank you very much for your presentation. We were kind of like around 5 minutes late on that, so I think we're gonna need to just reduce the amount of question answering. So we're gonna have time for a few questions. I think it would be easier if the audience can kindly raise their hands through the button that is on the lower side of the screen. If you can see the bar, there is like a hand sign that the audience can use in order to raise their hands. I'm not sure if Guillaume can see the people raising hands or if like there's anyone that has currently raised their hands.
I don't see anybody. Oh.
So, for example, I was just I was just mainly testing the system, but in general. So okay, so basically the Harm mentioned something that is one of the things that Harm mentioned that was very interesting was the assessment as one of the things that need to be captured in systems that is going to be covered by the next talks. There was one part that you mentioned on the slots that there was like a filling form. I didn't get that part particularly. So was it?
Do you mean, let me see if I can expand on that. So do you mean, so this is a standard, this one? Yeah, sorry. So this is a standard, more like Wizard of Oz, like user interface, where, so in this case, this is the user talking to so like needs to follow this script here on the right. And then there's the sort of like wizard who's getting these requests from the user and then needs to fill the slots here of the sort of like database query. So this is basically the programming that the wizard needs to do to get information from the database and pass it back to the customer or like user.
So the nature of the slots are more or less like the entities, or they're like the states related to, for example, to dialog state tracking, which is kind of
this is pure dialogue. You can call it dialogue state tracking as well. So it's really like type of hotel or type of food. You know, these slots that you often see in dialogue tracking.
Okay, see, cool. So other questions? No questions from the audience? Okay. So if someone is trying to raise their hand, but I cannot see it on the side, you can just turn on your microphone and go ahead. Okay, so this is basically the first time that we're using this platform in order to organize this event. So there might be some parts that we're not sure actually about. Let me take a look at the chat to see. Okay, so no, all seems to be in place. Once again, thank you very much, Harm, for your very interesting presentation.
Sure.
Okay, so we're going to move forward with the next talk by Nouha Dziri, who's a PhD student at University of Alberta and a research intern at Google AI New York City. And the presentation topic would be evaluating coherence in dialogue systems using entailments. So yeah, please go ahead.
Thank you so much, Hessam. So happy to be here and to talk about something that I enjoy working on, dialogue. Okay, let me first share my screen. I'm not familiar with
the The rectangle icon with the up arrow in the main toolbar should work.
Yeah, so okay, so do you see my screen?
Yes.
Yes.
Okay, great. Okay, hi everyone. Thanks for the introduction, Hissam. So my name is Nouha. I'm a second year PhD student at the University of Alberta. Also, I'm a research student at Google AI working within the language team. So today I'll be discussing some approaches about how we can evaluate open-ended dialogue systems. And in particular, I will talk about how we can evaluate coherence and consistency in dialogue using textual entailment techniques. So over the past decades, dialogue systems have exploded in popularity and have become omnipresent in our daily lives, assisting our daily schedule and routines. And dialogue system can be grouped into two classes, basically. The first class is what we call goal-oriented dialogue system, and the second one is open-ended, or also known as chit-chat or open-domain dialogue system. So basically, the goal-oriented dialogue systems are designed for short conversations, and also to accomplish a specific task within a limited number of dialogue turns. So the second and the search space for goal-oriented dialogue system is pretty narrow here, as we're dealing only with a specific goal, like booking a table in a restaurant or booking a flight. So here I'm not going to spend much time explaining the different challenges of both groups, and instead I will focus on the evaluation part for open domain dialogue systems. For open-ended dialogue systems, open-ended dialogue systems are designed for extended conversations and to chit-chat with the humans in an open domain context that could be about any topic. As opposed to goal-oriented dialogue system, the search space is very big, and this is due to the diversity of possible correct answers. So there are many challenges that we can face when building a dialogue system, and one of them is evaluation. So typically in goal-oriented dialogue systems, evaluation is done via a human-generated judgment like a task completion test or user satisfaction score. However, the task of evaluating open-ended dialogue system is not well defined, as there is no explicit goal for chit-chat dialogue systems. You can see that mainly the goal is to entertain the user and to engage in the conversation. So it's really unclear how to define a metric that can account comprehensively for the overall quality. Evaluation is extremely hard, especially for open domain dialogue systems. So many works have proposed different automated metrics. Examples include word overlap metrics, for example, bleu, météor, and rouge. However, these metrics have been proven to correlate poorly with a human judgment, resulting in significant biases across different models and data sets. Other approaches include perplexity. However, perplexity measures solely how likely the responses under a generation probability distribution and does not measure the quality of the dialogue. Also, some researchers in the NLP community often resort to human evaluation. However, this can be super expensive, time-consuming, and not scalable. Also, humans tend to evaluate a small number of dialogues, meaning that minor differences in the evaluation setup can lead to dissimilar results. Other works also can be classified under what we call model-based evaluation models. So these models target to train a deep learning model to learn human scores. So here I'm gonna mention some of the works that have been using a model-based evaluation model. So basically, Adam trains an RNN model to learn human collected scores for dialogues, and this approach relies on comparing the generated responses responses with the gold responses. On the other hand, the USR metric, it's a very recent work. It presents an unsupervised and reference-free evaluation metric for dialogue. And by reference-free here, I mean that we do not require true responses for comparisons. So basically, they train a regression model to predict an overall score for the responses based on some features like likelihood of the responses. Also, they come up with a binary feature predicting whether the response follows from the context. Another work here, also very similar to these work. It also was proposed very recently. It's called MOD. So MOD proposes an unreferenced automated evaluation metric as well that is based on learning from adversarial examples. So the model is designed to output a scholar score given the context and the responses. And the idea here was based on contrastive learning, where you discriminate between positive and negative responses. So now that I have discussed some of the challenges that we can face when building an open-ended dialogue system, here I'm going to talk a bit about how we can define and characterize a successful conversation. So social psychology literature describes how people achieve effective conversational communication in common social situations, and in particular, Paul Vries in 1975 proposed that a conversational logic can be modeled as a set of maxims known as Vries maxims. And these maxims correspond to the maxim of quantity, the maxim of quality, the maxim of relevance, and the maxim of manner. So let me here give more details about each of these maxims. So basically, the first maxim, the maxim of quantity, means that you should make your contribution as informative as is required, and you should not make your contribution more informative than is required. So unfortunately, current dialogue systems tend to violate this maxim, as they are often overly short and generic, and therefore less informative than desired. For the second maxim here, the maxim of quality, it means that you should be truthful. You should not talk about what you believe to be false, and also you should not talk about what you lack adequate evidence for. So you have basically to avoid to generate text that is self-contradictory or unfaithful to the, like the conversation history or the document that you ground your conversation on. So the third maxim here, the maxim of relevance, means basically that you have to be relevant and you should say things that are pertinent to the discussion. And finally, the maxim of manner here means that in the conversation you should be clear, you should be brief, and also you should avoid ambiguity. Current neural dialogue systems favor highly probable but generic words and phrases, and they lack adequate style. For example, the response could be on topic and relevant to the conversation history, but it could flout the maxim of manner, meaning the speaker responds with something that is not the direct answer to a question, but still this response is related to the conversation. So you can imagine this as a speaker who acts as an uncooperative communicator and tries to intentionally mislead, change the topic, or be unhelpful in any other way. Okay, so here I will talk about dialogue quality, but from another angle. A recent work from the Facebook research group looked at controlling the dialogue response generation based on some attributes, and these attributes correspond to repetition, specificity, response relatedness, and the question asking. So for repetition here, they try to avoid generating repetitive phrases within the utterance. For specificity, they try to be more specific and by making the responses more detailed in order to avoid having overly generic phrases. Also, they try to make the responses related to the conversation history by making them more topical, and also they try to balance between asking questions and answering them. So basically what they do in this work, they try to manipulate these low-level attributes and then measure their overall effects on the dialogue quality. So their motivation here is that a good conversation requires a balance between simplicity and specificity, between staying on topic and switching between topics, and between asking questions and answering them. So I find these qualities to be very aligned with the Grice maxim that I just discussed. For example, the repetition and the specificity can be classified under the maxim of manner. As we have discussed earlier, the response relatedness can also be related to the maxim of relevance. For question asking here, I can classify that under the property of engagingness. As in open-ended dialogue system, we want the dialogue to be engaging and interactive. So by asking questions, our conversation becomes more interesting. So we have discussed many properties that can make our conversation successful, and one of the properties that I believe is key for a successful conversation is consistency. So what I mean by consistency here is that the responses must be self-consistent, meaning that they should not contradict one previous utterances. They should be aligned with the conversation history, and also they should be faithful to external knowledge or common sense, and they should not generate sentences that are not, that are hallucinated, basically. So here, if you consider the following example between a bot and a human, so here the bot says, "I like Captain America and Star Wars." The human responds by, "What superpowers did you wake with?" And the bot responds, "I do not like superpowers." So you can see here that basically the bot just explicitly contradict what it said in the first utterance, and this is something that we don't want at all in a conversation. So in a recent work that we propose, we characterize the consistency of dialogue systems as a natural language inference problem. So in particular, NLI focuses on recognizing whether a hypothesis is inferred from a premise. So in dialogue system, we cast a generated response as the hypothesis and the conversation history as the premise, projecting thus the automating evaluation into an NLI task. So for example, here, if you look again to the example, if the bot responds by moving objects with my mind, we classify this sentence as entailment because it's following from the previous utterances. If the bot responds by "I don't know," we consider this as a neutral response because it's very generic and it can fit into any other dialogue context. And if the bot replies by "I don't know," like "I don't like superpowers," this is obviously contradiction, and we try to avoid generating these responses. So basically, our approach is very straightforward. We fine-tune a large BERT model on this task, and basically, here the task is to learn a function that, given the dialogue history plus the generated response, we want to predict whether whether the response is contradicting, entailing, or neutral. So to train our BERT classifier, we had to build our training data set. So currently there is no existing dialogue data set that deal with inconsistency in dialogue. So we build a synthesized inference corpus based on the persona chat conversational data. So basically, the persona chat conversational data was collected by Amazon Mechanical Turk, and here annotators were asked to converse with each other to get to know each other given some personas. So for generating entailment, for getting entailment example, we just consider ground truth responses from the persona chat responses as entailing example, as they were naturally as they were written by humans, and also we consider them as valid responses. For generating neutral responses, we just randomly pair our dialogue with random utterances from other dialogues, and also and finally for contradiction, we considered contradictory examples from MNLI. MNLI is a crowdsourced collection of I think 400K premise hypothesis pairs that are labeled with the 3 NLI labels. So the corpus covers a range of genres for spoken and written text. But it was mainly built not for the task of dialogue. And in our here collected data, we try to tailor our collected examples towards the dialogue task. So a very similar work to our work is called a dialogue natural language inference. And in this work, they also explore NLI for the purpose of improving the consistency of a dialogue model. So their dataset is also composed of premise hypothesis pairs that they curate as well from persona chat. In their work, they demonstrate the efficiency of NLI-based models in re-ranking a set of candidate responses through penalizing responses that are solely contradictory to a persona sentence. So to annotate their data set, they used human annotations from Amazon Mechanical Turk. However, in our work, we opted for an automated approach to generate training data, and this approach can be scaled arbitrarily and at a little cost. Okay, so to talk very quickly about here the results. So what we did in order to generate dialogue responses, we trained transformer-based models on the Reddit data. So this is our dialogue model that we use to generate responses, and then we use our BERT-based NLI model to predict whether the sentences are entailing, contradicting, or neutral. The model achieved an accuracy of 0.63, which is a reasonable performance as a first attempt to measure consistency in a dialogue. Also, our BERT-based dialogue NLI model outperformed existing out-of-the-box NLI models that were trained on MNLI, also Sitel. Okay, so just some takeaway messages here. Evaluating dialogue systems is far from being solved. Researchers are still on the quest for a strong and a reliable metric that highly confirms with a human judgment. Consistency is key in evaluating dialogue system, but there are many other challenges that we still face in building open domain dialogue system, for example, dealing with responses that sounds very natural, very relevant to the conversation history, but they are hallucinated. Also, finally here, entailment techniques lay the foundations of future works to evaluate better the consistency in dialogues. And I think this is the end. I'm very happy to answer any question you have. Thank you so much.
Thank you very much, Nouha. That was a bit shorter than I expected, but on the bright side, we have more time for the question answering. So anyone from the audience, you can use the hand icon in the control bar, and in order to raise your hands, and then you can ask your questions if you have. So it's either no one has raised their hands or there is an issue with the system. So I'm gonna start. Does everyone see me raising hands? Guillaume, could you kindly confirm that you see?
Yes, absolutely.
Okay, great. So the first question. So in your approach, do you mainly see your methodology in capturing the local consistency or the global consistency? By local consistency, I mean that, so what was the size of the context that you had before making the prediction? Was it usually large? Was it small?
No, so you can think of it as a local consistency here. We consider only 3 utterances in the conversation history, meaning that we want to predict whether the utterance would be entailing, contradicting, or neutral given the previous 2 utterances. So we're not really considering a very long context here. One of the challenges that we had is that we need a data set. We need to build a data set, for measuring global consistency in a dialogue.
Yeah, I understand. Yeah. Okay, thank you for the information. So now, once again, I'm going to give the opportunity to the audience. I mean, if anyone feels like they're raising their hand but we don't see it, feel free to turn on your microphone and tell us so that we know. Okay, so Guillaume has a question, or is it just testing?
Actually, I have a very naive question from from a non-expert, but I'm just wondering, compared to say asking people to grade the interaction or the conversation, what is missing with that, or why can't we do this, or why is it not sufficient?
It's not. I think it's not. Because here it's going to be super expensive, right? So if you're going to require human annotation, and we know that deep learning models are very data hungry, right? So we need to collect millions, let's say, of data points or thousands of data points. So this is going to be, first of all, very slow. So we have, first of all, to design our human annotation, and we have to, instruct the annotators on how they should, annotate each utterance given the context, and also given, we have to explain the task for them, what kind of properties we want the annotators to give scores for. So it's very slow. Second, it's very expensive. So we have to spend thousands of dollars to get a few thousand of responses that are labeled with human annotations. And here, as I said, so it's not scalable as well. So humans can provide thousands of examples, and we cannot scale those to millions of examples. So this is why we're trying to build, an automatic metric that require no human in the loop. I mean, that sounds very ideal, but we're working towards achieving that goal. But, so far we're very far from achieving that. So we're all the time requiring human judgment in order to see whether our automatic metric correlate with the human scores. Does that answer your question?
Yes, thank you very much.
Okay, so we have a question by Dr. Tapp.
Hi, thank you for this nice presentation. My question is quite easy. I'd like to have your opinion on how far we can go on entailment and logical consistency without using any discrete structure and only based on big, deep learning network of the type we are using right now.
Okay, so if I understood correctly your question, you're asking about how we are considering entailment without, I mean, I'm trying just to understand.
So how far can you go in computing logical statement from other logical statements only by using deep learning as a method? Do you think that we would need to use both discrete structure and deep learning, or what's the limit, you think, of the kind of logic that can be learned just by a neural network on examples?
Yeah. So the hope from using deep learning is that these models can learn implicitly. I'm sorry, the logic structure of NLI textual inference here. So I think that using deep learning can with the right data for sure, can provide a proxy for us to determine whether the response follows from the context or not, whether the response is contradicting or not. So I'm not really familiar with the logic structure here, but I think that there is a promising direction in exploring deep learning with NLI. For sure, it's not sufficient, as we can see, applying, out of the box NLI approaches to evaluate consistency in dialogue here, right? Because in dialogue system, we can, like responses can be, problematic. They can be hallucinated, they can be off topic, and we can see that using only 3 labels like contradiction, neutral, and entailments is not sufficient to detect these errors. I don't know if I answered your question, but I think we need a better data here if we want to use deep learning in order to detect, problems within, like these problematic responses within the dialogue systems. But for sure, this is not enough.
Well, thank you very much for sharing your perspective on that difficult issue. I appreciate your talk.
Thank you so much. Thank you. Okay.
I don't see other questions, so.
Sorry, I think that I was muted and was talking for a few minutes and I didn't recognize it. I'm sorry. So I'm gonna proceed with asking a question, if it's okay. So I was wondering how you see the use of external knowledge sources in these types of tasks. Like, do you think that incorporating a knowledge graph or, kind of encoding the knowledge, embedding the knowledge inside these models is actually going to improve the performance in terms of the detection and consistency, or not? So I was wondering what's your idea on that?
Sure, definitely. Here you're talking about groundedness. Are you talking about grounding the response on an existing knowledge, on like structure or unstructured knowledge here? So
no,
if
I was actually not grounding the responses by the agent in the system, but actually grounding the predictions of the model in such tasks. So, for example, the case that you mentioned earlier, that I don't like superpowers. So I personally didn't see it as something inconsistent. So I wouldn't personally like to have superpowers, but I like watching superhero movies because like having a superpower would be something I don't want to live in a fantasy life, but I enjoy watching fantasy movies, or I enjoy reading about fantasy stuff. So like there might be different perspectives on these types of, labeling consistency and things related to that. So I was wondering, like, having an external knowledge source and grounding the methodology, the predictions on those, how would you see this is going to affect the system? And do you see actually an application of grounding in these types of tasks?
Sure. Yeah. So let's start first by talking about whether grounding the response on external knowledge can be beneficial for the dialogue system in general. So I think that here, if it depends really on your ultimate goal here. So if you want the dialogue system to generate truthful responses, what I mean by truthful, these responses should be aligned with common sense knowledge, or also general knowledge that exists, like let's say in Wikipedia, or that was validated by everyone. So yes, for sure, we need to ground that on external knowledge to make sure that the responses are not only faithful to the document, but they are also truthful. But if we're just, we're trying to generate a response that is only coherent with the dialogue system, with the existing or with the previous utterances, maybe we don't need here per se external knowledge. Maybe if your dialogue is super huge, and in this case you want to maybe build a knowledge, a personalized knowledge base for this task. Maybe the model, it would be easier for the model to have access to that knowledge graph and to extract or retrieve information that are relevant to the current utterance. So here you are requiring the model to generate sentences that are faithful to the conversation history, but not necessarily truthful with respect to general knowledge. And for sure, this can be super. This can be a nice application, right? If we're talking about educational chatbot, so it's not tolerated to have a chatbot system that tries to educate you about something, but it generates something that is not faithful to the document that you ground on your information. And also it's not tolerable to generate responses that are not truthful with respect to general knowledge. Yeah, I feel that it's a very nice, it can have a very nice application here.
Great. Thank you very much. I really appreciate your answer.
Sure.
Other questions? Okay. So seems like there are no more questions. So thank you very much for your very, very interesting talk, virtual clapping. And okay, so we're going to have a break for a few minutes, for about 10 minutes, and we'll be back at 3:25 after the break. So in the meantime, please enjoy a coffee, and if you want to have some snack or anything, and we'll be back at 3:25 with a talk by Sarath Chandar, and we'll continue the event from that. So in the meantime, enjoy. By the way, please don't leave the meeting. We're going to be here. The meeting will not be closed by that time. But yeah.
Sam, I think the schedule is a 5-minute break.
The schedule is 5-minute break, but the case is that we're kind of 5 minutes ahead of the schedule. We actually added another 5 minutes at the beginning. We kind of started 5 minutes later, but this talk lasted shorter than expected. So I think 3:25 would be okay.
Yeah, okay.
So, hi again, Sarath. Hello again.
Hey.
So I'm really looking forward to your presentation. Is it like kind of in the in response to the other paper that says how not to evaluate your dialogue system?
Well, kind of.
Cool. Yeah, I'm looking forward to reading it. And I also took a look at a paper. Like the interesting part was that the finding that you had regarding recurrent neural networks are kind of better in inference than transformers. That was really interesting. I'm really looking forward to see more details on that. Okay. Okay, so hello again, everyone. I hope everyone is back from the break. It's 3:25 today, right now, and we're going to continue the event with a presentation by Sarath Chandar, who's an assistant professor at Polytechnique Montréal and MILA. And the talk will be on how to evaluate your dialogue system. I'm really looking forward to see the presentation. So without further ado, please welcome Sarath.
Thank you for the introduction, Hassam. Let me share my screen.
The rectangle with the up arrow button.
Yeah. Okay. Can you guys see my screen?
Yes, you can see it.
Okay. So I think I can start. Okay. So thank you for inviting me to give this presentation in this consortium. So I will be talking about how to evaluate your dialogue systems. So it's nice that my talk is after Nouha's talk, like she has set up stage for my talk. So before I begin, like I just want to highlight that the work that I'm going to present today is primarily done by Prasanna, who is a PhD candidate at McGill / MILA. So this is a couple of projects which are in joint collaboration with Prasanna. Okay, so I think I don't need to give motivation for dialogue systems in this meeting. Nevertheless, dialogue systems are considered as holy grail of NLP and AI because it involves a lot of understandings which is very hard for machines. So why do we need dialogue systems? So there are at least two ways in which people use dialogue system. The one is dialogue as a purpose, where the goal itself is the dialogue. The examples include chit chat systems or bots like Wobot, like which is a mental health chatbot. So in this scenario, the dialogue itself is the purpose. On the other hand, like you could also use dialogue as an interface, which was covered by Harm's talk. This could include things like goal-oriented agents or Google Assistant or Apple Siri or Amazon Echo, where there is a purpose which is other than the dialogue, which the agent is trying to achieve, but by using dialogue as a mean, right? So these are the two different ways in which people can use dialogue systems. So this talk is not about how to design a dialogue system or a neural dialogue system, which is currently the state of the art, but we will focus more on evaluation. So to motivate the importance of evaluation, like here's an example goal-oriented conversation. So the user is saying, I'm in town center and I need somewhere to go. And the agent says there are 40 attractions near you. Can you narrow down what you would like to see, right? So now from this response, like we can see that the agent needs to have some knowledge of the subject matter, right? So it needs to know something which is external to the dialogue sometimes to answer or respond to the user. So the dialogue continues. So user asks, okay, user says anything is fine. Send me to your favorite place in the city. Just be sure to give me the postcode. Now, the agent has to understand the conversation structure and it has to understand the intent. And it also needs to understand here that it has to provide a postcode. Now, again, this involves some external knowledge query to find the right postcode for the favorite place, right? Then the agent says, the Man on the Moon concert hall is my favorite. Like, this is the postcode. Can I help you with anything else today? I'm looking for a train from LE to Cambridge. So now the agent has to actually handle multiple tasks, right? Like, so in the beginning of the conversation, the agent was trying to find a reasonable attraction, like a place to visit for the user. Now the agent is being asked to book a train, like find a train from LE to Cambridge. And now the agent has to ask a couple of follow-up questions to figure out when to book the train. And it gives an option, which is train TR 2987, right? So now looking at this conversation, like we could see that dialogue systems, like dialogue generation is much more than language modeling. So it involves extra factual knowledge that the agent has to remember or even know how to access, and it has to understand the intent of the user, and it has to know the higher level intent of the conversation, right? Like, so there is way more understanding which is involved here than just plain natural language generation. Okay, so here is another example, like, but from the other type of dialogue systems, which is chit chat systems, right? Like, so in this case, here is a conversation where the user says, I'm worried about something, and the agent is asking, what's that? And the user says, well, I have to drive to school for a meeting this morning, and I'm going to end up getting stuck in traffic, and so on. So the main point in this conversation is there are a lot of subtle details, like the fact that the user is worried, like the fact that he getting stuck in traffic is annoying, right? Like, so, or being empathetic to the user and asking, okay, is there anything else bothering you, right? Like, so there are so many subtle details involved in this conversation. And remember that this conversation have no agenda. This is a chit chat. So there is no goal that the user is trying to achieve or the agent is trying to achieve. And even in such a plain, like, open dialogue scenario, there are many, many details other than just plain language modeling, right? So these two examples like kind of tells us the importance of both language understanding and language generation. So while we give so much importance to language generation and see dialogue as a generative task, there is a lot of language understanding that needs to happen before the system can actually start generating something meaningful. So here is a grid which shows, like, what does it mean for a dialogue system to have, for example, very bad language generation skill as well as very bad language understanding skills, right? Like, so then probably that system doesn't even understand the task. And on the other hand, like, so recently with GPTs and T5 and other big transformer models, we have systems which have like really good language generation skills, but their understanding is still bad, right? Like, so now these systems kind of overfit to the surface level tokens. So even though on the surface level, it looks as if the system is fluent in the dialogue, like its understanding is still zero or like close to zero, and that system is still not a good dialogue system. So we might have systems which have good understanding skills, but bad language generation skills. Like, that is still not very useful. It has a broken generation pipeline. But what we are trying to achieve is to design systems which has good language understanding skills as well as good language generation skills, right? Like, so something like humans, right? Like, so that is what we are aiming for. So now, this is our goal. The goal is clear, but the next obvious question is, like, let's say I come up with a new system. Let's say I come up with a neural network. It could be a recurrent neural network, or it could be an LSTM with attention, or it could be a sequence-to-sequence transformer model, right? Like, so now I come up with a new model. Now, how do I evaluate both the language understanding and language generation capabilities of this dialogue system? So maybe first let's start with appreciating the fact that dialogue is totally different when compared to some other NLP tasks. For example, dialogue is not language modeling. Most of the language modeling focuses on like situations where the response to the context is coming from an entailment, but that is not the case in dialogue, right? And dialogue is not machine translation, simply because in machine translation, given a sentence, like the corresponding response in a different language comes from a finite set of possibilities. But in the case of dialogue, like the corresponding answer or the response that the system could give is potentially very large, sometimes even infinite. Like if someone asks, how are you doing? Or like how do you feel today, right? So like the dialogue generation process could be very, very open-ended, unlike machine translation. And the dialogue is not just question answering. It's not just about like answering based on facts. There's a deeper context which runs throughout the dialogue. And there is also a higher level goal which needs to be achieved by the process of dialogue. Even in a chit chat system, there is some purpose, but we just don't know the purpose or intent in a chit chat system. On the other hand, for goal oriented systems, we clearly know what is the goal, right? Like, but there is higher level goal which needs to be achieved, and it is missing in a simple question answering system. Okay, so this means that like dialogue is not like language modeling or machine translation or question answering, but how do we evaluate such dialogue systems? So some of like I think the previous talk covered some of the evaluation methods. So some standard evaluation metrics in the literature includes like perplexity, which is primarily used for language modeling. People also use Blue and Rouge, which are primarily used for machine translation and borrowed from machine translation. And recently with neural networks, like we also use embedding based metrics like embedding average or vector extrema, which computes the embedding similarity between the target sentence and the model's response. So these are metrics primarily used for summarization, but in some sense, we don't have a clear metric for evaluating dialogue systems. So we always borrow these metrics from other NLP tasks. And one of the seminal papers, which came out in 2016, explained that none of these, or demonstrated that none of these metrics correlate with human judgments. So this is the famous paper which talked about how not to evaluate your dialogue systems. But that paper only talked about how not to evaluate and not how to evaluate. So what we are going to see today is like, in some sense, like a follow-up question to the paper, like in which we are trying to answer how to actually evaluate a dialogue system, right? Like so okay, going back to this 2016 paper, like this paper had a big assumption that human judgments are the best possible evaluation for a dialogue system. Okay, so and through studies, they showed that none of these metrics correlate well with human judgments. So this led to a bunch of follow-ups in dialogue evaluation. So the primary observation is, okay, human evaluation is good, but the problem is human evaluation is costly, right? Like, so every time you train a new model, like you have to set up the human evaluation in Amazon Mechanical Turk, and you need more humans to do these tasks. One, like it requires more people, like it requires more money, it requires more compute, right? Like so you like it takes a lot of time. So the moment you introduce human in the loop, your model prototyping becomes slow. Like the time it takes for prototyping a model increases. So there were a bunch of papers in the last couple of years which started introducing metrics which were mimicking human judgments. Okay, so methods like Adam or Ruber or Mode, like so they started like training a deep neural network which would try to predict the human score, like given the context and the response. And in some sense, now the human evaluation is automated by these metrics, which are actually not very perfect, right? Like so they have their own issues, but the goal here is to replace human evaluation, but by using these metrics which are mimicking the human judgments. Again, these methods also make the crucial assumption that human judgment is the best way to evaluate dialogue systems, right? So the problem with these approaches is like they need to be retrained for every data set. So like I would like to start this talk with the question, are human evaluations actually sufficient? Okay, human evaluations have a lot of problems. So first of all, humans are very subjective, right? Like so we have subjective opinions on what is the right, what is wrong, and there's a lack of appropriate ground truth for every context, in which case it could lead to more variance in the evaluation. And there is also a natural bias that humans have to specific answer types. And there is limitation in providing full context for evaluation. So normally when you do human evaluations, like you cannot show 6 turns or 7 turns and then ask what is the next response, right? Like so it takes a lot of cognitive load for the human or the mechanical Turker. And often when people do human evaluation, they're going to reduce the context size or they don't show the extra information that the system has access to, so that it becomes like a cognitively simple task for humans. And the evaluations are also not scalable. So even, okay, so these are the issues, right? Like, so but we wanted to understand if, like if there is any, like if we wanted to understand if like it is actually worth like trying to handle all these issues and still do the costly human evaluation. So to understand this more, like, so we set up this task where we sampled responses from 2 different seats of the same model and performed human evaluations on a simple question, which is which of the 2 responses is appropriate to the context. So to highlight the significance of this experiment, remember that we took the same model. It is just the seed which is different. And we also made sure that the model has very less variance. And hence, in some sense, both the seeds have very close blue scores or almost close blue scores. Okay, see, these are not 2 very different models. The same model, different seeds, similar performance. So now we collect 3 responses for 2000 contexts from this by using 500 human participants. And we sample 10,000 sets of 200 out of 2000 contexts to plot the score distribution. So one would expect that the agreement between the user, like the humans, is going to be very high, simply because these are 2 different, so these are 2 models which are like really same and have very similar performance, right? But here are the results. So here you see that the fraction of ties, which is supposed to be at least close to 0.7 or at least more than 0.5 for this setup, right? Like, so you can see that the fraction of ties is less than 0.5. So for all the 3 human experiments, like we have the mode around 0.35 to 0.4, which is very low when compared to like what the setup is, right? Like, so this raises more question about consistency of human evaluations. And remember that human evaluation is costly. So often authors of papers would just pick 1 random seed for your model and 1 random seed for the baseline model and compare like which is good, right? So now there is more chance that like just by chance your model could be better. It could just be the random seed which is responsible for the ratings that you're seeing in your experiments. And this is not really like trustable anymore, right? So how now the immediate, okay, the next question is like how to remove humans from this evaluation loop, since we think humans are not consistent in their evaluations. So this leads us to probe tasks for evaluating dialogue systems. So what we propose is, like, instead of using a human to evaluate the system in the end for every new model that you're designing, like we expect the data set to come with a set of probe tasks, which are actually human designed, right? Like, so we are kind of redirecting the human effort from evaluation to creation of probe tasks. And once a model is trained, we just take the state of the model and run these probe tasks to understand or to analyze the language understanding capabilities of this model. So here are some example probe tasks. So like we have like different varieties of probe tasks that we have designed. Some of them are information specific. So the colors here actually indicate the difficulty level of the probe task. Like, so some are the green color tasks are easy, yellow is like medium, and red is difficult, and so on. So I'm not going to explain every single probe task. Like instead, maybe I would like pick some of them. For example, all topics is a task which asks the system by giving a context, ask the system what are all the topics that we have discussed so far, and it's a multi-class classification problem, right? Like, and similarly, for example, the slots, all slots is basically what are all the informations given by the user so far. This is suitable for goal-oriented dialogue systems. And so one of the most difficult tasks that we have is personal info, which is based on persona chat data. The question is, what characteristics of your persona can you infer from the history, right? Like so similarly, like we have some tasks which are downstream based, right? Like so, like these are primarily used in like goal-oriented systems where you have slot and corresponding values, and there are also certain semantic tasks which are more on like the length of the conversation, fluency of the system, and so on. Okay, so these probe tasks are going to be helpful in evaluating the language understanding, which is something totally missing in most of the automated evaluation metrics. Right? So most of the automated evaluation metrics are still looking at language generation capability. They are not looking at the language understanding capability. And as we discussed in the beginning, like so, it is very important that we evaluate both the language understanding and language generation capabilities of a dialogue system. So again, like so, what we are doing here is essentially redirecting the human effort from evaluation to creation of probe tasks. So now we are going to take. Okay, so maybe before I go to the experiment, like I just want to highlight the fact that the idea of probing neural networks is not new. It has been used in several other fields. Like so, for example, there are a lot of probe tasks for language generation testing, which could all be added to our probing tasks as a collective benchmark for evaluating the dialogue systems. And there are probes for representation learning in reinforcement learning, where given a representation, you're interested in understanding like what are all the information that this representation is encoding. And there are a lot of probe tasks done in computer vision and even in dialogue. One of our previous work did a probe task for finding whether models like RNNs and transformers can model the sequence information efficiently. So there are like different probe tasks like used in different contexts. So what we are essentially trying to do here is to highlight the fact that probing is like one efficient and scalable way of evaluating dialogue systems. Okay, so now let's get into the results. So here are some results for multi-verse data set, and we compare 5 different models. So as I said in the beginning, like the focus of the task, like focus of this talk is not on the models. I'm not going to explain these models, but I assume everyone is familiar with LSTMs, bidirectional LSTMs, transformer. HRED is hierarchical recurrent encoder decoder, which is basically an LSTM model, but with hierarchy, like 2-level hierarchy. And there's LSTM with attention decoder. So here are like some of the probe tasks, and one of the interesting result that you would see keep repeating in all my future slides is the fact that recurrent models are doing better than transformers in most of these probe tasks. So you can see that except for repeat info and num repeat info, which are simple tasks with one or two, like with 2 classes, in most of the tasks, LSTMs, bi-LSTMs and LSTMs with attention are doing better. And HRED, which in theory should be better than LSTM, is still not doing well, and transformers are clearly not doing well. And you would see the same trend in all the tasks all the probe tasks that we designed. And we also have some results on persona chat, which is more of like a open chat data set with some persona for the agent. And as I said a few slides back, like personal info, even though the goal of this data set is to have an agent which has some persona, this agent doesn't know or understand anything about the personal info. So all the 5 models that we tried had almost close to 0 performance in the personal info probe task. Okay, so another interesting observation is the fact that for all the models except transformer, their performance in these probe tasks increase as the training proceeds. On the other hand, transformer is the only architecture where the language understanding capabilities gets worse and worse as the model's fluency increases. So this is common trend in all the like tasks that we have tried. And in some sense, this highlights the difference between recurrent models and transformer-like architectures. So this is in fact one of the themes in my research, like where like I'm trying to understand why transformers work and like so under what circumstances recurrent networks can be better than transformers, right? Like so this is another this is yet another interesting project, like where we found that recurrent neural networks are actually better in language understanding when compared to transformer. So there is actually an intuition that we developed by empirical experiments. So here you can see how the encoder hidden states evolve for 4 different architectures, like bi-LSTM, sequence with attention, plain LSTM, or transformer. So one thing that you can notice here is the scale of, so these are like PCA plots, like these are high dimensional embeddings projected to low dimensional embeddings. So you should take that with a pinch of salt. But one thing that you should highlight, like remember, one thing that I want to highlight here is the fact that is the scale of these embeddings. And you can see that transformer has such a large scale, which is in the order of hundreds when compared to LSTM and LSTM variants. Right. Also, you can see that as the epoch continues, LSTM is trying to compress information into a low dimensional manifold. On the other hand, transformer is actually spreading out information. Like it already starts with such a high dimensional manifold, and it is really being good in like memorizing everything that it can memorize, simply because it deals with much larger manifold when compared to recurrent architectures. So in some sense highlights the difference in inductive biases between recurrent networks and transformers. Okay, just to conclude this part, I want to highlight that the models that we considered are actually not very different. So if you just look at the blue scores of these models, their blue scores for bi-LSTM sequence to sequence and sequence to sequence plus attention are very similar. HRED is worse, but look at the blue scores and you can see the transformers are actually doing much better in terms of blue scores. So they are able to produce really fluent language by overfitting to the context and the response, but their understanding is not as great as like sequence to sequence recurrent network models. Okay, so what further can we do with these probe tasks, right? Like, so probe tasks are not just for language understanding. So you could also use probe tasks for other things that you want to test in a dialogue system. So one of the problems that we often face with like completely automated generative dialogue models is that your model can be unempathetic at times. So here is an example, like real example conversation sampled from four different models. So the user says, I once called my girlfriend's mother by accident. And you can look at the response by like 4 different models, where bi-LSTM says, did you have a good time? LSTM plus attention says, that's so sad, what happened, right? Like, so you can, and LSTM says, oh no, that's awful, did you have a good time? So you can see that sometimes the dialogue systems could hurt the customers. And as an industry which is deploying such systems, it's very, very important that like you don't have systems which are unempathetic to your customers, right? Like, so now to avoid like deploying such system and actually to have a check on the systems before we deploy to like real life applications, like so like we also came up with a benchmark called Progress, which is a framework to probe the gender, racial, and emotional sensitivity of generative dialogue models. So the premise here is the dialogue models generate responses occasionally without being sensitive to emotional context. And like what we are trying to answer here is like, can the potential insensitivity be quantified with probe task? And hence I could have a threshold and say, okay, so this particular dialogue system that this team has implemented is not good enough to be deployed, right? So to do that, like, so we came up with a bunch of probe tasks which are specifically focused on emotion, gender, race, and so on. So just a quick note that most of the public data sets do not identify any individual with their gender, race, or emotion state. So instead, like what we have is a data set independent set of tasks with some data sets. Like for example, in this case, EEC stands for Equity Evaluation Corpus, where the races are identified with, like the users are actually identified with European and African American. So we used some external data sets to come up with these tasks, and these are general enough that you can actually use these tasks with any open domain dialogue system that like you come up with. So once we have the probe task, now we could ask a lot of questions, right? Like, so the first question that we want to ask is model inductive bias the reason for the issue, or it is the data? So this is a very interesting question.
Okay,
yeah.
so sorry, Sarath, for interrupting you, but we're kind of exceeding the, but it would be great if you can
continue. Yeah, I'm finishing in 2 minutes.
Thank you very much.
Okay, so like the question here is like, is the model inductive bias the reason for the issue, or it is just the data, right? So here are like two different models with completely different inductive biases, like BiLSTM and transformer, and we are comparing across data sets, and you can see that there is a gradient of difficulty on the probe tasks. Even though BiLSTM models perform better or some of the probe tasks, like they still need a lot of improvements. So one of the main conclusions from these experiments is that the data sets have different effects on different inductive biases. So it is very hard to decouple the bias that is arising from the data set and from the inductive bias of the model. So where does the potential cause of insensitive responses lie, right? So to do that, like we did further analysis on the embedding space, and we found that for most of these models, like there's no clear difference between the emotions. So which is like one way to avoid this could be actually to add some sort of way to discriminate the emotions, but then you are adding a bias to the model, so you don't want to do that, right? So systematically studying such problems is very, very important if we want to deploy dialogue systems like in the wild. So I would like to conclude this talk with a few takeaways. Like one is probing tasks are scalable methods for evaluating dialogue systems. They are more consistent than human evaluation and also more scalable. Like right, like so, like you could automate the process. And each dialogue data set, we think, should come with a carefully selected set of probe tasks designed by humans, so that whenever people are developing new models, they could do a lot of analysis instead of just plain blue score computation or roach computation. So we also need dataset independent probe tasks like progress to verify the functionality of the systems that we are going to deploy. I think this is very important, and in some sense, this could be considered as unit tests for like software systems which can actually talk and interact with humans, right? Like so in some sense, unit tests for dialogue systems. Okay, sorry, I took a little bit more time. So the talk was based on these two papers. One is already in archive, and the other one will be released soon. And I would also like to highlight the fact that Prasanna is finishing his PhD. He's in job market. So if you are working in dialogue and you need more expertise, you should contact Prasanna. Any questions?
Okay, great presentation. Thank you very much, Sarath. So any questions from the audience? Okay, so once again, I'm gonna start the questions. Like in terms of the way that they process the data, do you see any reason why the transformer is working worse than recurrent neural networks when it comes to the probing, but when it's like in terms of the generating quality, like in terms of the blue score and stuff, it scores is higher? So do you see any reason if it is relevant to the way that it processes data, or?
Okay, so I think there are a bunch of things to consider here. Like, so one is the fact that most of these dialogue datasets are like small scale when compared to like other big scale datasets that we have for other tasks, right? Like, so typically like a decent like goal-oriented dialogue dataset would have 10,000 conversations, which is not a lot, right? So, and for models like transformers, which has a lot of capacity, they can easily memorize the context response pairs. And so there is a lot of debate in the community about whether GPT, the progress by GPT is actually impressive or not, right? Like, so these transformer models, even though they are very fluent in their language, have like very minimal understanding. So I think we haven't made a lot of progress in language understanding as much as we have made progress in language generation with tools like transformers. So in some sense, these probe tasks are highlighting my belief that like none of these models are good in language understanding.
Okay, great. Thank you very much. Questions from the audience?
Yes, I have a question. It's Harm here, Sarath.
Yeah. Hey.
Yeah, thanks for talk. I just had a question and maybe just some some food for thought. And so, like, do you think, like, in what sense is this related to like more this like dialogue state tracking or having a sort of like more internal representation that people could interpret, right? So,
okay,
like we've seen like now. So like we've just seen like everyone is crazy about like neural nets with continuous representations, but at the end, like people wanna, oh yeah, what does my model actually understand? And we're gonna discretize it again and like make a structured input. So how much do you think that we'll need to maybe refigure like the way we're designing our models, like to bake that in the first place?
Yeah, I think, okay, that's a very good question, which was in fact one of the motivations for us to start this project. So like we observed that most of the progress in neural dialogue systems, at least, is actually like borrowing ideas from sequence to sequence and and building upon the success of machine translation, right? Like, so in some sense, what has happened is, so I think the dialogue community pre-neural network era was more thoughtful in like understanding the structure and stuff with slots and context, like slots and like filling the slot values and so on. But then like they were missing the generation capabilities. And what neural dialogue systems are doing is, so they are kind of completely throwing away the structure and like the information which is the main focus of the dialogue, and focus a lot on generation capabilities. So in some sense, like these probe tasks can be seen as a step back in like going back to the old slot value system dialogue models, right? But there is a difference. The difference is we are still working with neural dialogue models. It is just that we are tracking their progress by using these slots and like probably more structured questions. So maybe this would motivate us to come up with like more informed architectures for dialogue systems than just simply treating dialogue as a sequence to sequence model. So for me personally, treating dialogue as a sequence to sequence is the biggest overkill that you can do for dialogue, right? Like, so it is not just sequence to sequence. So it's very difficult. It's very wrong to like, trivialize dialogue as sequence to sequence.
Right.
So that's what we're trying to argue here.
So I agree. I'm just trying to understand what your concrete or like more concrete proposal is, because like there's also issues with slot filling, right? Like in some sense, it's a very rigid structure that you have to define some fields in advance.
Yep.
And maybe potentially you can extend it to a graph, like semantic machines just recently proposed. But of course, then that like if you're gonna like there's the spectrum of like rigidity, right? Like from slot filling with slots all the way to continuous like representation. So what do you think, like what's kind of necessary? Like I guess there are a lot of like young researchers in this presentation here. So like what do you think like as a high level would be good to focus on?
Okay, so it's okay. Well, it's very hard to answer that question, right? Like in some sense, like the focus of these projects are more on the evaluation side. So there is here's the thing. This work is not this work or myself like I'm not like saying that slot-based models are better than sequence-to-sequence models. So in some sense, like we don't even care about what the dialogue system is like. So we treat dialogue system as a black box for these probe tasks, and like we are just trying to evaluate their understanding. So we are using slot information, but in a totally different sense. We are not using the slot information in a way that we expect the model to treat these slot information internally and try to come up with predictions or generations. Instead, we are using it only for evaluation. So if you ask me what would be the right architecture for doing dialogue system, I'm not sure. But all I can say from these experiments is like current like recurrent architectures or transformer based architectures are clearly not sufficient. And even more important message here is you cannot replace everything with transformers, right? So these results show you that like they have very poor understanding. Even though the understanding of recurrent networks are not so great, the performance of transformers are even worse, right? We don't see any language understanding improvement in the evolution of these probe tasks.
I agree. So I just want to push back. Like, I'm not sure if we're going over time and we should stop here, but I just want to push back a little bit on.
Sorry, Harm. I have to leave, but I do believe that the meeting will continue if I leave. So
okay.
Yeah, hopefully. So goodbye, everyone, if it closes.
Yes, I think it should be fine.
Hopefully it will be.
Thanks a lot.
Okay. Thank you,
Really
Guillaume.
appreciate the talk.
Thank you.
Yeah.
There is a very interesting conversation going on here, so we'll leave it as is. And Dr. Tapp wants to add something. So I was wondering if it is relevant to this, the same conversation, or is it a separate question, Dr. Tapp? Hi, can you hear us?
So yeah, I will move to the consortium update for those that are interested. There's another invite with another link. Thank you again.
Okay, thank you. So it's still, I'm not sure if the meeting will still go on, but I think it will.
So I mean, I'm just gonna talk to Sarath. Like everyone who wants to leave is free to leave, I guess. Yeah. So like, I guess my concern like about like transformers versus RNNs is really like the data regime that they shine in, right?
Yes.
So like transformers, like, I mean, people have been banging their heads against the wall with RNNs just because they can't model long-term context with a lot of data, right? So
yeah.
and so like the task that you're evaluating on, you're in a regime that RNNs are fine, you know.
Yes, that
so
is true.
It's clear to me that yeah, that's sort of like it remains to be seen what happens in a setup where you actually have a lot more context and a lot more data.
Yeah, that is true. But there are also some other non-dialogue work where like people at least try to demonstrate that transformers are not very great in reasoning tasks, but maybe it's just a question of coming up with a better architecture. At the same time, right, like yes, you are right. Like, so if you have lots and lots of data, then maybe transformers could start understanding things, right? Like, but you might not have so much data for every task. So maybe like a safe way to say this is like exactly what you said, like which is like different models have different operating regimes, and depending on like which regime is your task and data set, like maybe you need to pick the right type of model.
Dr. Tapp wants to ask a question, so please go ahead, Dr. Tapp. We still can't hear you. I think you're muted. Or could you try again? We unfortunately can't hear you. So
Okay, he says the meeting has to end so that they can start the next meeting.
Okay, sure.
Okay.
I actually don't have the link to the other meeting, so I'm not sure. So did he send it here?
Well, I think there was a separate invite.
Okay, I think we can just say goodbye to everyone from here. Thank you
so
very
Han,
much.
let's catch up offline.
Yeah, sounds good.
Thank you very much, everyone, for staying here. I really appreciate it. It was great. And please stay tuned for the upcoming events. Thank you and bye.
Bye.